Hello and welcome everyone to another session in the DataHour series. We are thrilled to be here with you this evening for a session full of action-packed learning. I am Priya Pandey, part of data science team at Analytics Vidya, and we have Rishikesh Kokare, who will be moderating the DataHour session with me. For those who have joined us for the first time, a brief introduction to the DataHour sessions. The DataHour is a series of webinars conducted by Analytics Vidya and led by top industry experts. It is a fun way to understand the concepts of data science from leading players in the data tech domain. And as the name suggests, it is 1 hour dedicated to data. We are hopeful that these sessions are going to be great source of enrichment and value adding for our community members. Now on to the our speaker today, which is now on to our session today, which is NLP aspects in telecommunication industry. Natural language processing (NLP) is an art and a unique technique for analyzing modern data like speech, text, noise, etc. It has changed the game of telecommunication industry remarkably. In this data, the speaker will explain how machine and deep learning along with NLP can make sense out of this modern data. She will elaborate how modern data processing is done and how telecommunication industries are using the NLP technology to draw meaningful insights for their benefit. I hope you all are excited to attend this data hour with us. Before we kick things off, and I hand it over to our speaker, a quick recap of the housekeeping items. We are recording the session, and the recording will be available on our YouTube channel. You can find the link in the chat section. Please use the Q&A section for asking any question you might have during the session, and we will do our best to answer them as the data progresses or towards the end. Lastly, we will share a feedback poll towards the end. You all are requested to kindly fill that up before leaving the session. Now on to our speaker in this session of Data Hour, we have Sakshi Gujral with us. Sakshi Gujral is currently working as a data scientist at Concentric. She is also pursuing her PhD from IIIT Delhi. She is a GATE scholar and a UGC NET qualifier as well. And most importantly, she was alumni of DRDO, that is Defense and Research Development Organization. So over to you, Sakshi. The virtual stage is all yours. Thank you.
Well, thank you so much for the lovely introduction and a very brief for the course of the data art. A very big thanks to Analytics Vidya who has invited me for this session. So a very big hi to all the audience here. I can see people from various countries have joined. Thanks a lot. So let's begin the session. This session would be on NLP in the telecommunication industry. So I am coming from the industry and it has been almost like 4.10 years to me working with the various kinds of the data, and out of which one industry that I still feel will be growing and have variety of modern data is the telecommunication one. So with this, I'm going to share my screen so that we can begin with the session. Any doubts in between, any questions you people can post and I would try to answer. I hope my screen is visible.
Yes, ma'am.
Thank you. So natural language processing in telecommunications. So I would say past 3 years has witnessed a lots of changes in the data. So earlier we used to have data generation from the conventional banking sources, finances, and like very conventional sources. Now, but with the increased use of social media, the amount of the data has increased a lot. Now, every domain, I would say, is having the data. And telecommunication is one such domain which is growing at a very fast speed. And this data, I would say, would be a new oil factory in the upcoming years. And it can provide us 100 of insights, which 100 of tasks, I would say, which can lead to million and trillions of the insights from this data. So natural language processing is the data where the way we speak and the way we try to speak in different regional language, such becomes the natural language. So natural language is no more restricted to speaking only English. Now, if I talk about the regional language, especially in the countries like India, where I would say only Hindi is not the language. Hindi keeps on changing its aspects in every different regions. So that also becomes a part of a study. So very frequently across all the globes, natural language processing is done on the English language. So here in today's data hour, we are going to cover such topics in the English language itself. So I have structured it in a way where I will be introducing you more of the NLP stuff. We will talk about some applications of NLP. We'll talk about the basic pipeline that would be a little bit technical of NLP. Then I'll come to NLP in the telecommunications overview. And at the last, fifth and sixth point that I have noted here, I would be showing you some Python code so that you can get an exposure that how we can do some interesting stuff with the help of the code as well. So we'll cover some stuff with the basic machine learning and finally the advanced deep learning algorithm as well. So I would try to cover from basic to advanced. Like the moment I'm going to wrap it up, you'll have a knowledge about the basic NLP stuff, and you will try to learn more for the advanced one as well. Okay. Now, with this diagram, let's try to study how this language processing is generated and how it can be understood. So it's like we can see here there is a person who is talking, like what is your return policy? So that conversation is being recorded in the form of the text data. Now, comprehended what is being said, the way we are going to understand it in terms of the computers, that becomes the natural language understanding. Now, what after this? Like we have understand, we as a human have understand, but how to make our machines understandable to it? We need to do some code. We need to do some processing. So once we have done this processing, once we have done the code, what next? Like this is the data. Once the data has been processed, we can see what is being talked, but now how I can make use of this data to gain some insights out of it. Then machine learning, deep learning comes into the picture. So there are two pipelines, machine learning and the NLP. So one NLP is used to capture the data for the natural language processing. And once the data is being captured, to make some more interesting stuff so that we can go for the automation, we require machine learning and deep learning. So here in the diagram, we can see machine learning can help us to determine the right response. And further, with the help of training the machines, we can go for the natural language generation. So a simple example would be a bot to whom I have trained certain English words. Now it has learned with the help of the machine learning algorithms. Now this bot itself can start producing some natural language. The moment we are going to write something, it is capable enough to generate the entire sentence. That comes the natural language processing going towards the natural language generation. So it is NLP turning to NLG. Now, I have included a slide just to have the real life applications where you can link NLP in our day-to-day basis as well. So very simple example is the sentiment analysis. So whenever you go to restaurants or go for a movie, you always find some feedbacks where you are supposed to submit few stars, or maybe you are supposed to write some reviews about a delivery boy or the food. That becomes a sentiment analysis. So it actually helps industries. So it's just not the summation of stars. It's easy job for us, but how if I see from the industrial point of view, from the business point of view, at the back end, all the biggies are trying to analyze the data, their service, their So if I talk about Swiggy, Zomato, the customer feedback for a delivery executive is really helping them a lot to track the performance of their staff. So this is how simple sentiment analysis is saving the money of many of the biggies, and they are ready to spend a lot on doing this sentiment analysis, trying to improve it with the passage of time. Now, beneath it, we can see a person is talking to Alexa. So I think Alexa, Google, every day we try to speak, we try to set the alarms, we try to use them so that we can change the music and do tasks for us. So this is another beautiful example of NLP, which is used in day-to-day life. And natural language processing market on the right-hand side corner, the top one, we can see we try to analyze the market trends as well as. So wherever there are some comments, so there is textual data involved, offline or online, that can be processed with the help of the natural language. Now, how important is NLP in mobile? So any answers for this? I would like to see some answers in the chat window for this question. Anything that you people can think of. I'll stop for 1 minute. Chatbot, analyze people conversations, Google Translate, nice. I'm getting good responses. Social media text, assistance, machine translation, WhatsApp, very nice. For purchasing items. Calling numbers, okay Google. Customer satisfaction, wonderful. Vertex AI, the advanced content moderators, ticket classification, Siri. Wonderful. So I have got lots of answers for this. Thank you so much. Yes. So you people have written already that how important is NLP in mobile. So the recent times where mobile phones have improved a lot in terms of both hardware and software, we can say this: mobile phones are now the wallet of data. Whatever activity we are trying to do, Google is analyzing, and other features or apps are also analyzing this data. Why are they analyzing? So that they can make use of this data to improve their service, bring out into the market the new automations which can really help us out. Now let's try to be a little bit technical about the NLP stuff. So we see lots of data on the social media. So not only it's like social media data or data which is present into the digital forms can be an NLP applications. If we have bunch of documents itself in a form of a PDF where we like it's on a paper and we try to scan them, click a picture, we can still use the data from there and get it analyzed with the help of NLP itself. So number one example is finding appropriate documents on certain topics from a database of text. Now, if we see searching queries, if we try to search for a particular document using the conventional algorithms, it can really take lots of time. Searching is a cost to hardware and to I mean there is always time and space complexity involved when we are searching. But if we know the correct document, like some keywords, or with the help of NLP, if we try to do the same searching operation, the operation time would be less. Secondly is extracting information from messages or articles on certain topics. For example, building a database of all stock transactions. So NLP give us the very sophisticated applications to write the regular expressions. So regular expressions can be written without NLP also, like some people who are using APIs, gateways. So those people make use of the regular expressions to get the authorization tokens. But if we talk about the NLP stuff and the associated libraries for writing down the regular expressions, those are like quite powerful, especially if I talk about Python and R. Third, if I have to translate the documents from one language to another, for example, the producing automobile repair manuals in many different languages. So if we make use of the NLP, that it would be again efficiently used. So these are some of the examples where some of the work has been done, and researchers all around are trying to improve the model performance so that they can bring out some more new techniques and improve the accuracy of the existing work. I think someone has raised the hand. Is there any doubt? Okay. Now it says summarizing text for certain purposes. So instead of going for a 1,000-page documents, I would try to extract the relevant information from this document, and then I would prepare the summary. So that would not be a manual process. That would be again an NLP process. That NLP gives me and a power so that I can extract the directly keywords from all those corpus 1,000-page reports and get the important words out of it. Question answering systems. So modern days question answering systems where NLP is used to query a database, those have also been upgraded from the NLP point of perspectives. Now, lastly, I would like to introduce that in the telecommunication domain, automated customer service over the telephone. So we all try to call this customer service, not only in the for the telecommunication one, but for the other services, like sometimes our cards are not working, or some airline. So they start recording the text, and that text is being analyzed. So that is again a very useful application, and it is still a very important research area which engineers, scientists are trying to improve the accuracies, trying to make it more efficient. Coming to the next slide. So this is a very general diagram which would give you a gist for all those who don't have exposure to NLP before, that how a NLP systems looks like what are the stages into it. So we get a text. Usually the natural language processed text contains lots of noise. So when I talk about noise, it means messy data. The data can contain the repetitive words. It can contain the hyphens, at the rates, some emojis, and special characters. So that needs to be pre-processed, because wherever I'm going to apply machine learning, I have to make sure that the data which has to be given to the machine learning models, though that has to be in the highly sophisticated represented form. Otherwise, model will not be giving us the good results. We are not going to train it in a proper way. So I would be doing some text processing. Sorry. And then second part is the EDA. EDA is exploratory data analysis. So very first thing, whenever we get any type of data, whether it's a numerical data or an image data or a video data, we should try to look what is contained into that data, the insights, the actual trends. This is how data scientists work. What is actually contains, what is the distribution of a variable, because we should try to deliver to the clients that this is your data, it contains so and so trends. Now from this trends, I can try to bring out some more insights, or we can do XYZ task onto it. Now, when we talk about EDA, once you are giving the insights, your next step should be the feature selection. Now, if I say I have a CSV or an Excel that contains 1,000 columns, not all 1,000 columns are useful to me. So I would be selecting some subsets of columns. That is a feature selection. For that, I use some of the embedding techniques. So there is an example of word-to-vec. Word-to-vec is an embedding technique which tries to find out or extract the important information out of the text. And then we come to the representation part. So representation part in terms of the NLP or any other advanced data, modern data, is quite important. Reason is that if we are representing in our data, that would help us to improve the modeling part. So if the data is messy, too many dimensions, and it's not in a proper form, so model will not be able to process it in a way it should be. So this representation itself is a good research area where lots of research is being going on, especially for the text and the image data, as well as sound also. Now, next comes the modeling part. So here, depending upon the task, like if I want to do classification, if I want to do some regression, if I want to do clustering, I would be selecting the model. And depending upon the size of the model itself, I need to take the decision whether I'm going to take the deep learning model or a machine learning or other stuff. And finally, it is a deployment part. But make sure that all machine learning models are not deployable, because these take cost again into the times of the time complexity and the computation complexity. So sometimes it happens we are not actually deploying them, we are just keeping it and running it iteratively, like a quarter or 6 months, to get the data dumps and process the model, and then analyze the results and then make changes. So that's also a way some of the organizations are doing. So I pause here for a moment, and let me check if people have any doubts. Okay. So I have received a question, what is the meaning of EDA? I mean, in acronym for what, please? Okay. So probably I'll take the doubts. I think at the end of the session, you people can post it.
Yes.
Okay. Moving on to the next slide. Okay, so this diagram, if we look for the very first time, can be a little bit scary. But this is important to understand, because later on I'm going to show you from the coding point of view, how does it works. So number one step, as we have read, data pre-processing comes into the data cleaning, and then it comes into the tokenization. So let me give you a very simple example. Let's say I have a sentence, Ram and Sham are playing. So this is entire sentence. Now, this entire sentence cannot be processed directly by a machine learning model. What I have to do, I have to first of all break my entire sentence into the words. That breaking of entire sentence into the words become the tokenization. Then I try to bring out some important information from those tokens. Then I do POS tagging. POS tagging is part of speech tagging. That means, just like in English, I have got pronouns, nouns, verbs. I do the same way. But I would say that 4th and 5th, these are the steps we don't usually use in all the use cases, depending upon the requirement. It's just an EDA part. 5th is named entity recognition. So once I have broken down my sentence into the words, what I will be doing, I'll try to find out the important keywords from the sentence. It can be not only a sentence. I mean, it would be definitely a document where I would be using analytics. So the frequency of the words will be given by the named entity recognition. The important words, I can have it from there. And then depending upon that, I will try to do some more computation, as we can see at step number 6 and 7, that I will be doing some lemmatization. Lemmatization is like Ram and Sham are playing. So playing itself is a token, but I cannot use ing into it, because that's giving an unnecessary information to my machine learning model. So I'll try to convert my playing word into the root form. So that is being done by the lemmatization. So we have got a couple of libraries in Python where I can do various techniques where lemmatization can be formed. And then I try to extract the features, that is like n-gram extraction. So it means from Ram and Sham are playing, from this particular sentence, how many words I want to analyze at a single go. Like 2 words would be a bigram extraction. If I want to take 3 words simultaneously, that would be a trigram extraction, similarly like this. And then I would be performing some task like classification, clustering, depending upon the requirement. So in any case, if you people are not clear with this slide, that's not a big issue, because it's more of the technical stuff. I'll try to show you for the coding part that would be more clear to you at the end of this series. Now let's talk about NLP in telecommunications. So telecommunication is receiving variety of data from their grids, from their customer support office. So this is one of the industry which I have chosen today to talk about, because this is receiving the data in the form of the time series data, some textual data, also the images of the towers. So numerical data, grid data, some data like this. So it is receiving variety of data to be analyzed. So I have worked on one of the client, which was not only one of the, I mean, I have a decent work experience for working with the telecommunication clients. So I would like to share the same information with you, that how we tried to solve these use cases for them, and that actually helped the business out of it. So as we can see from the diagram, we can see the very first use cases, system of records. So they have got most of the telecommunication clients have their CRM systems where they can capture the data. Now this data can be coming from the chatbots, SMS, social media, voice, and the video chats, and also in terms of the marketing data. So campaigns can be run off to collect the marketing trends in these strategies. Everywhere the data is, we can see for this particular diagram, is more of the NLP based data. Now, once it is being done, they have got some IoT stuff also, like some wearable device data, cloud data. So every data is being collected at the central level, and then to analyze this different type of data, which is actually a textual data, most of the time they try to build out the pipelines. Now, one such example I would like to give. So there was a client, a telecommunication client of mine, who wanted to make sure that whenever the network parameters it is providing to the customers is aligned with the post they are posting onto the social media. So it was a case that if a telecommunication provider is providing me an internet service, suddenly my internet has stopped working. Now people start posting, giving their hashtags, that let's say hashtag ABC, that this provider is not providing me a satisfactory services. Now what happens if such type of comments are being recorded onto the social media? This can actually hamper the business. So there is a loss to the industry. Now, what to do in that particular scenario? There are two things. Track the of grids that are supplying the internet, and to track the social media or any other platforms apart from all this force which I've mentioned here, that whether they are aligned or not. So this was the use case that was being approached to us, and we provided the solution in such a way that we combined the data from the one of the social media portal, that is Twitter, and also the data provided by the client into the form of CSVs, that was a network parameter data. And thirdly, we had another social media data, another social platform that contains the again the data similar to the Twitter point of view. So I'll tell you about that also. So first of all, let's see what kind of data we can have from the Twitter. So single tweet can give me a plenty of information, like who has posted, the geographic location, the sentiment of the person, along with the emojis. So emojis itself is another research area where emojis, memes detection, this can happen with the help of NLP, because they give us, these emojis can be mathematically converted back into the text and the further numerical values, and then they can give us that how happy or sad a person is with the help of these services. Information, fourth point, information about the operator being tweet and subtweeting, that is metadata about the tweeters, retweets, and live tweeting about the short events. So these are the 7 points I have included here, just to give you what important data we can get it from Twitter. There are a couple of other columns also that you can include in your code and get the relevant information. So what I have done for this particular use case, I have used the customer provided the data that was being provided by the telecommunication client. Tweets I have extracted from the Twitter, and there is one more platform called downdetector.com that is like quite famous within US, that maintains the records of the problems. And then this website allows people to post the comments whenever there is a downtime. So data from the downdetector.com and data from the Twitter actually helped us to get an aligned and to give a good picture that whether there is a network failure or not. So I chose a particular date on which there was a network breakdown. So it was somewhere around 19 July. And then I tried to scrape the Twitter data for that particular date. I also went to downdetector.com and then check the stats for there. So we can see here 83% of the people have reported that internet was not working, 10% reported TV was not working, and 5% said it was a total blackout. So this is how this base was built up. Now we did the Twitter sentiment analysis for this. So what we do, we try to observe from the tweets when the outages happen, and then it was the using the Twitter API, and then I did a sentiment analysis onto it with the help of a machine learning model, that is logistic regression. Logistic regression is more of the statistical model, I would say. So I'll explain all this stuff in terms of the codes also once I'm done with this particular piece. Now, with the help of this Twitter sentiment analysis, how it benefited the client, how it benefited the business. So it gave us an approach that if the models are being trained, it can give us the timely actions that which factors are important for the network providing services. And if we provide the good network services, definitely it would improve the customer experience. So it can also give us a good idea that so and so are the peak hours where the internet requirement is more. So in that particular scenario, organization can take a step that I need to supply more of my internet bandwidths during like evening peak hours or morning peak hours, wherever the traffic is more, and then it can definitely improve the business. And what was the outcome of this? I was able to find out what all top 10 frequent words that are being used by the customers. And then I had a model which can classify the tweets, like whether a customer is happy or not with the service, with the 82% of accuracy. And if we can see here, out of the 1,000 tweets, so first it was tested on a very small data. We just came out with the conclusion that 840 people were not highly satisfied by this. So I take a pause here. So I just wanted to know from the response that are you people following it, getting it, or is it like making sense to you? Okay, thanks a lot. So before going forward, I would like to show the small Python code that how we can do this. I'm going to share my screen back. Just give me a moment.
Yes, ma'am.
Yeah. So now I will be showing you a Python code that how I did the scrapping of tweets. So this is the Google Colab, the online editor that I have used. So there are a couple of libraries that I have used here and set up here just to save the time, out of which one was a preprocessor. So and then Twitter API. So before scraping the data from the Twitter, I need to make sure that I have a Twitter developer account. So Twitter provides the open API. Twitter provides the developer side from there, from where you can get some consumer key, consumer secret. These are the credentials. So you make an account over there. Your tokens will be generated. These tokens would be having some lifespan, that is they can expire as well. So whenever you want to scrape the data, you need to make sure that your tokens are alive. Once you are done with it, so Python provides TWP from where you can extract the data. And once I am done with it, I can do a search words. Search words give me method that hashtag this word, I want to fetch the tweets from this. And then with this piece of code, I can specify in which language I require and how many counts, I mean, how many tweets as a single hit of this API I would be requiring, and from which date. So there are 100 of other things you can do with this. When you are hitting the API, you can include more of the columns. So I have just used it the way I want, nothing else. So Twitter developer documentation can really help you. It can give you longitude, latitude, and other information. You can always use it. And then with the help of CSV file, CSV writer, Python package, I am able to extract the tweets and save into a CSV. So I would like to show to you the similar way I try to scrape this data from the Delhi violence. So let me show you how this tweets looks like. So I can see here, these are my tweets. So date is coming, username is coming, from which location it is coming, and these are my tweets. So this data is quite messy. If you can see here, there are lots of handles, there are new lines, there is a time. So we cannot use this data directly. We need to process it, and then find out the distributions of the words. It's not always the numerical data that can be visualized. We have got lots of opportunity to work on this textual data to get very good insights from this. So this is the small example where I have showed you how to just grab the tweets. Now I will be taking you to the another notebook where you will be seeing that how I use this tweets to classify the data that I have showed to you in my presentation for one of the telecommunication client. So I'm sharing my screen back. Yeah. So this is a small code we have done. Logistic linear regression is quite basic model. Since the data set we wanted to test, it was a solution. For the solution point of view, we should not go and apply very complex models. We should go for this basic statistical model because they give us a very good results. These are not the black box models. These are like white box. You can see how statistically the results we are getting. So once I have scraped this data, I have split it into the train and test CSV, and this is how my data looks like. So there is a column called label, which is 1 and 0. So this I would say the tedious task of the NLP and to get a label data. So how to solve this task? Number one approach is that once you are having the data and you want to label it, label means whether a customer is happy or not. 1 is happy, 0 is not. There can be other stuffs as well, where we can find out some more categories, like a multi-class classification problem where we have tons of data and we need to classify that data into the 5 clusters. I would say there also you require a label data. Number one is you can sit with the domain team, the operations team, that can really help you to guide from the domain point of view that which data should fall into which category. Number two is you can write some code. So with the help of the Python, NLTK and SPACY. Specifically for the SPACY, I would say SPACY can give me this entities creation, entities creation functions, which can help me to get this labeling. Thirdly, we can make use of some paid resources which can label the data. So very famous is Amazon trunk services, which can help us to label this data, because label the data at first point is costly, but if I look for a long-term ROI, it's good. If I have trained my model with a very good quality of data, definitely, and I keep on doing some task iteratively, it will reach to a point where I can get the good prediction out of it. So this is how my trained data looks. This is how my test data looks. So here we can see label is having NEN right now because I want to test it. I want to make my model to do the testing onto it. Now, since the streets are highly messy, highly dirty, I need to clean it. So we write some code. So it's a function called remove pattern, where I try to remove the handlers which are not making sense to me. Then Twitter handlers have been removed. So I'm not going into the much detail of this. This is how I'm showing you that it can be done. Then with the help of, these are called some regular expressions. These are also regular expressions, which can help me to do the cleaning of this data. And now we can see how my tidy tweet looks like after cleaning this. So this is again an intermediate process, intermediate step. I can still clean more of the data. Now, this is token. So we have talked about this in the NLP pipeline. So we have tried to split our data into the into the words that are called tokens here. And then, sorry, we talked about the lemmatizers. Lemmatizers and stemmers, these are two approaches for extracting the roots out of the words. So we did here the same way, so that we can just like very simple example, doing is here, it is do now, because ing given to the model will not give me any good information. So that's why with the help of stemmers or the lemmatizers, I can do the same task. Only difference between lemmatizers and the stemmers is that one gives you the words that is a dictionary meaning, and one can give you any abruptly words. So once we are done with it, we go for the vectorization. This part, vectorization or embedding. This part is like when I'm trying to convert my text into the numerical form, because text I cannot give directly to machine learning. I need a good representation. So at the beginning of this session, I told you about representation is a very good research area. So yes, so the more concise your data will look like, the more better the presentation, the more it has been observed from the literature surveys or from the research point of view that your model can give you the better results that are making sense out of it. So for this particular part, I have used count vectorizer. It's a basic one. Now we have got we have got very advanced embedding techniques that are being developed by Google, Facebook, and other A&T labs also for doing the same stuff. So I have used here both count vectorizer and TF IDF vectorizer. So these both of them involves a lot of mathematics behind it. So if I try to explain you those, it will take another web series to do the same. So that's why I'm just giving you the flavor that how do they look. So they basically try to do what? They try to give the numerical values based upon the frequency of words across all the documents. Now, with the help of the sklearn library of Python, I have used this logistic regression. Why logistic regression here? Because it's a simple binary classification problem, whether customer is happy or not, 1 or 0. If I would have been given a lots of data and a multi-class classification problem, I would have not been chosen the logistic regression. And then with the help of this, I calculated F1 score. So because of the classification stuff is there, we don't choose this accuracy. We generally go for the F1 score. So once your every stuff from the NLP to machine learning model is being done, you need to evaluate how your approach has worked. So that's why F1 score is there. And then finally, I have written the data to the CSV file. Now, this is one of the visualization I wanted to show you, that I got top 10 frequent words. There are 100 of other visualization ways through which you can show the various stuffs, do the very good amount of EDA. You can create bins, histograms, heat maps, and I would say box plots to do the same. So this is what I have done. So I take a pause here, and again, I would like to hear, so was this coding part clear to you? I'll quickly go in the chat window just to get your responses, and then we'll move to the another part. Yeah, I've received word cloud. All right. Yeah, there are questions that I will be taking for sure at the end of the session. Okay, I'm going to share my screen back. So this was the basic modeling part that we have covered, from the basic NLP stuff to a small use case. We'll now go to the advanced one. So these are just the snippet of the results that I have showed to you. Okay, now again, let's move to the NLP in the telecommunication. So telebots, SOM bots would be the new technologies that we will be seeing in the upcoming futures. So telebots are already into the place. SOM bots would be there. So how do they work? They get some data from IVR, websites, call centers, back office, apps, email chats, and the social networks. These telebots, based upon the data and some input from the customers, they try to create a tickets. So these tickets can be an order cancellation, order creation, payment process, ticket resolution, provisioning, and technical response. So let me give you a more simple example. So right now, if I have to book hospital appointments for like hospitals that are quite famous in Delhi, I would say, Fortis and Max. So you simply go to the website and a chatbot appears very suddenly, and it asks you, what are you facing, where you want. So it automatically creates an appointment to you, and that gets delivered into the WhatsApp. So that's an example of telbots, chatbots, we can say. And at the back end, what is the use of this? This data is being created the moment you type the data, that is being stored into the one of the database files. So organizations are receiving your data. Now, no more a person calling who is not answering a phone is required. So that frustration has been decreased, that a person is not answering our calls, and organizations also are not missing the data. So it is good for both business and for us. Now let's move to the last and the interesting, I would say also the difficult part of this session. Now I would be giving you a use case. I will be taking you to a use case which involves the deep learning. So there was one of the problem that approached us from the telecommunication client only. It was a telecommunication client based out of the Spain, and we were based out of the India. And the problem was that their business was falling off there. And then what was the issue they wanted to track, so that they can restructure the entire internal process. Now they had called a manual ticketing process. So what was happening, let's say I'm calling to a help desk person and I report that so and so grid near to my home is not working. That's why I'm not receiving the signals, like there is an indoor coverage problem, or there's a radio coverage problem. If the moment I step out, I don't receive a signal. So all those conversations are being recorded by this help desk people, and they are trying to create a ticket or event, we can say, based upon this conversation, and they were trying to resolve them. So what was happening, because of all this manual process, the SLAs, that is the time in which they have to solve a particular ticket, was not up to the mark. So when SLAs are not up to the mark, they cause a lots of business impact. So they wanted to restructure this process, and then they have approached us. Now, challenge was for us was that data set was quite small, and we need to give them the approach so that we can get a more business out of it, and then it should be integrated into the form of a chatbot type APIs at their level, so that they don't require more of the manual ticketing process. So 86 JSON files were delivered to us, and it was the text but into the Spanish form, not in English. Now they have also shared us 4 manually created Excel files, and one document that was a data dictionary document. So that was being delivered from the client side, and it was restructured from our end. Now, the most serious task when we talk about the industries is the data procurement and data validation. So if I get a data and I'm working as a data scientist, I need to make sure that that data is enough. It contains the attributes or the columns which should be enough to solve a particular use case. If it is not, then being a techie, you should go and approach to your supervisors or the stakeholders that this data is not sufficient, and we should get more data that should make sense. And you have to spend a lots of time in understanding that data, even though you are working into the same domain, because data understanding can give you the better connect with the data. So just first thing is that whenever you receive the data, create a data dictionary, and with the help of the past experience from your supervisor or someone from operations can really help you out. Now, we need to focus what are the tickets that are being reported, what are the parameters we need to process, like text part, description field in the data set, and what are the parameters or the columns. When I'm talking about the parameters, these are the columns which were being shared into the CSV format, that like the entire CSV was shared, and then there were a couple of columns, and based out of the NLP approach, once I have done the classification, I need to update the columns like category, criticity, priority, and the ticket type. So all this stuff needs to be updated by the NLP engine. So this is the solution which we have prepared. The very first task is that all those Latin languages, Spanish and the other European languages, we don't have sophisticated Python libraries or the R libraries to process them, as well as for the low-level regional languages. So we do have a good resource for the English one, but we don't have the good or the efficient one for this Latin and the low-level Indian languages, I would say. And so there were 2 approaches. So whatever is available, we should try to pick it up and then make a model, like whatever few libraries are there. Or the another approach would be to convert the Spanish data into the English one, and then do the pre-processing and bring out the result. Now, when we were doing the conversion from Spanish to the Google one, we can see that the context of the sentence was being broken down. So what happens, the moment I have converted the entire conversation from Spanish to the English one, I can see now the English version, but the context was broken down. Now, what is the next step? I don't know Spanish. None of the team members were aware of it. So we again interacted with some of the translator Spanish speaking person, so that we can validate our data set, so that our model should get maximum accuracy. So data science stuff or the NLP staff at some point can require this interacting with the person who knows a particular language as well. So it would be a teamwork, not a single data scientist can handle it in a good way. So ideally for the NLP staff, if you are working in any language that is apart from the English, you would require someone from the operations to understand the data, you with your technical skills, as well as someone to validate your natural language who is aware of that particular language in which you are working of. Now, what happened? There is a data source here. We can see in this architecture diagram was a trouble ticketing data. So whatever tickets that have been created manually by the customers, those are being stored here in a data source. Now, we have stored them in a data storage, proper data store. And this real-time message ingestion, it was like in the near future, if they try to give the real-time input also, how this chatbots would be behaving. Now, if I talk about just the data storage, from the data storage, if I pick the data, then I follow these steps for the pre-processing that we have talked in the entire series. The tokenization, stop words removal, stemming, normalization. So normalization is like bringing the data into the standard format. So if it is like one data is highly distributed and one data is not, so we need to make sure the ranges are matching with each other, so that it should not be here. In case of the text data, ranges is like the frequency distribution. So I need to make sure that those are like aligned to all variables. Then duplicate data should not be given to any of the model, because it creates the redundant information. And if there is any misspelling, removal, that also needs to be done. And then finally creating corpus. So creating corpus means the vectorization converted into the numerical parts. So once it was being done, this NLP engine, we did some extensive EDA, because EDA is the only thing which can help your client to understand more about the data that is being offered to them. So it's like your data, an organization is giving you data, but they really don't, but they have hired you because you
I think there's some disturbance with the network thing, I guess. Give us a second, guys. Oh, okay. We need a couple of minutes to figure this out, guys. Just a minute. We are just fixing it. Please stay tuned. We're fixing this issue.
Deep. So if I talk about algos like BERT, RNN, KNN, Deep NNN, so these are quite advanced transformers, BERT models. These are quite advanced NLP models which can help me to do lots of tasks with the text data. So this specifically I have included here that these models are in the, we can say, the trend of analyzing the large amount of data as well as big data. So big data is not only the data which contains the higher dimensions as well. So finally, with the classification report that we have created, we shared them the classification that whatever tickets they have classified at the month end, like the customer, the help desk people who has created a ticket that a person is faring a radio coverage problem or an indoor coverage or an outdoor coverage problem, we compared that output with the output that our model gave and reported the accuracy. Also, we have updated the priorities, which tickets should be more priors in the near future. So this entire pipeline was delivered into the form of an API with the data when we got in a large amount. So we tested with the small one. Once it was okay, we tested on a larger data, and it's currently also with that organization into the form of an API. So now it's like the model they try to trained occasionally, like after 4 months or 6 months. I think the frequency might be this only. They try to re-improve, they try to increase or decrease the categories so that they can play around, and this has majorly solved the problem of breaking down SLAs which was happening at their side. So this has saved a lot of business. So this is all the summary of the explanation that I have given to. Here I wanted to highlight that we have used here LSTM. So LSTM model is a deep neural network based model. So I would like to give an overview for this because explaining it and code for this will take another an hour to do. So for this particular data session, I will give you an overview. So first, let's go to the second figure. So let's see this. This movie is awesome. So let's try to understand that whenever I get a data set like a movie review data set, that textual data set gets converted into the form of a matrix. This matrix we can obtain technically from the coding point of view by any of the embedding techniques, or maybe some vectorization techniques that I have showed to you. So this is required. This is a representation part, which is a research area that is important, a step before the model. And then I try to extract the important features from this matrix. And then again, I try to keep on reducing the important features with the help of various techniques. And then I give this feature maps to the LSTM model. These are the different LSTM units. Now, LSTM is a long short-term memory model. So it was a successor of a recurrent neural network. So these neural networks, RNN or LSTM, they have a capability of storing your long sequence of data. So the traditional machine learning algorithms, which can help in the classifications like naive Bayes, logistic, they don't have a capability of retaining the entire sequence. So there comes these type of algorithms into the picture, because the context could be like, he was a good player, but he was not playing well. Not playing well changes the entire context. So we need some algorithms that can create some that can create the probabilities, or I would say the context for the entire sentence. It should not be biased by just the single words. So that's why these algorithms RNN came into the picture. Number one, RNN came into the picture. Then it had some drawbacks, so we went for the LSTM unit. If we see in the first diagram, the green color one, here we have a control that what to do, what information we want to give to the model, and what information we don't want to give. So those are called control gates. So this view is something like a hardware view. So those people who have, we all have studied XOR gates, NOR gates in the digital electronics, and then this is the same. The very first X is an input. Input here is a embedded version that we give it to it. Also, it keeps the, if it is like x input, it also maintains the x-1 unit, the sequence. And then as we can see here, cross sign. So we are just trying to control what information we require to give or what information we don't want. And then from that LSTM model, the multiple LSTM model, we can do the classification. So for this particular use case, we did the multi-class classification model with the help of NLP and the LSTM. So that's all from my side. So these are
yeah, thank you so much, ma'am.
Yeah.
Okay, before we proceed to answer your questions, I would like to request the attendees to please fill the poll about feedback as it helps us to conduct more such sessions. So I'm launching the poll and then we'll continue with the question answer session. Is it okay to you, ma'am?
Yeah, sure.
Yeah. Okay, guys, so I've launched the poll and we'll continue with the question answer thing, ma'am.
Okay.
Now, yeah.
All right. So I can, since I joined back, so I cannot see many of the questions. It would be good
Yeah.
if you can.
Yeah, sure.
So
I'll just filter it up for you.
So someone has posted, which is the best form to bring into our code NLP task implemented our own or embedding algorithms or BIBs already implemented. So for embedding purpose, I would strongly recommend first to, if your data doesn't require much of the, your data requires more of the analysis task at the later stage, try to save the effort and make use of the embedding techniques which are already being developed by Facebook and Google, because those techniques have been launched after training on very huge data sets across all the years. So it can, even though you try to implement yours also, it will not be that much powerful as those which have been already in place. Secondly, question is, will the voting approach among all the tech algorithms help to improve the accuracy? Yes, it can help. So if we try to use multiple algorithms, we can get the idea that how much accuracy up and down we are getting. And if, let's say I have 5 algorithms and one of the algorithms, say XGBoost, is giving me the best results. Now algorithms accuracy will improve more with the ingestion of the more data as well as more of the iterations. If I use hybrid approach, this can sometimes improve the accuracy, but not all the times. Another question I can see here is social media customer query response. How do we achieve it? What kind of model we use for emoji response? Yes, so for emoji response, name detection and other stuff, again, these advanced models that I have just talked, BERT models, transformers, these are quite advanced, and these can actually use for both image data as well as text data. So you can make use of those. Emojis can be directly converted into the textual or the numerical one later on. How do we provide personalized response on tweets? Sorry, I'm not getting this question. Okay, now let me go to another questions. Is there any API of Amazon products to do the sentiment analysis for each product? So eventually, there is lots of research going on for this particular stuff. Amazon has opened few of the APIs, but we cannot track entire product information from there. So it's still a close for us. Okay.
Okay, I can see some of the question in the chat, Q&A section.
For the ticket, sorry, yeah, please go ahead.
So it's in NLP, can we use linear regression and other type of regressions?
So I just showed you, we have used logistic regression here. So in NLP, we can definitely go for some linear regression if my problem is to predict. But most of the time, NLP use cases are most of the time it's like a clustering or a classification problem that I have observed. So linear regressions you can use, for sure you can use. Logistic I have used, but if a use case require, you can use it. Language translators are available, like Google Translator. Meet your input. I'm sorry. Yes, is softmax used in NLP? Yes. So softmax is an activation function. The output we get after applying the deep neural network at the end, we require it to be delivered into a form which is understandable. So in that particular scenario, softmax is definitely useful. And I see one more question. For the ticket dataset problem, how the voice is converted to JSON. So eventually for that particular thing, they were making some short notes. As soon as they are hearing someone from their client, they were making these short notes. So it was a textual data that they were capturing, and JSON was a patient, sorry, not patient. JSON was a customer specific. So each JSON contained each customer information, and it was like a customer ID and how many conversations during multiple days they have done for a particular customer. It was containing that. So all the conversations were merged out to give a final conclusion for a customer level. Another question is knowing maths important for becoming NLP developer? Statistics is required. Statistics and probability is required not only for an NLP developer, but any field requiring data science aspects like a computer vision or a simple time series data analysis. You require statistics because the model, how they are behaving when you deliver them into the form of evaluation metrics. So just like today I have showed you F1 score, you cannot interpret and give to your client the results unless and until you are not aware of these stats behind it. Knowing copy code is not enough, because if you really want to play out with these algorithms, just using sklearn will really not help you. Try to understand the maths behind it so that you can have your own algorithm. But eventually you can start with the sklearn libraries only. Another question is, along with the black box algorithms, is it suggested to use white box? Not all times. So sometimes your stakeholders, they are not at all from the statistics background. So they just know this, that input is given, I'm spending this in this on a particular stuff, and I'm getting this much response. They don't get a white box information. It is hard for them to digest them as well. So in that particular scenario, you should try to represent your results into this, that you were spending money on, let's say I have 10 columns that impact my business. You were spending money on this 10 columns, but I would recommend you to spend more money on 5 columns so that you can have a better business. Try to understand into the give them the download so that in a layman terms. Okay. How duplicate questions, that questions can be found by NLP. So duplicate questions is like mathematically when they are going to be converted, their numerical value would be closer, like 0.36. And just give an example of 0.36. It can be, depending upon the representation you are choosing, it would be different. It can be a matrix as well. It would be similar. So there are other similarity measures also, which can help you to correlate that these problems are similar. So it would be a duplicate question. You can drop them off. I think I have, okay, last question I can see. When building a portfolio for an NLP developer, what kind of things employees are looking for? Statistics, Python or R, and then I would say deep neural network, because most of the time in the big organizations where these chatbots or the NLP work is happening, they are now switching to this deep neural network algorithms. I think
Yeah.
I'm done with the questions.
Yes.
No,
Thanks a lot, Sakshi.
yeah, thank you.
Yeah. On behalf of Analytics Vidya, I'd like to thank you. I would like to thank you for your time and for delivering such a wonderful session. I'm sure our audience found it insightful, and hopefully we can conduct more such sessions with you in the future.
Sure.
Yeah, I hope you, yeah,
And thank you to all the audience here for
yeah,
such an interactive. Without hearing a single voice, I can see a lots of questions
yeah.
coming from the chat window. That means people were attentive during the
Yes,
entire
very
session.
much. And they got panic because because of the connection issue.
Yeah,
Yeah. So that is the thing that people are very much interactive here. So I hope you guys have filled up the feedback poll. If not, I request you, I'll relaunch it if possible. Because your feedback help us to conduct more such sessions, and we'll be back with another session of Data Hour on 22nd of September. And the link is in the chat box. Till then, bye bye and happy learning. Thank you so much, Sakshi, for a wonderful session.